pleasant morning to you, ma'am. Our presentation is entitled Exploring Mathematical Concepts, Systems of Linear Inequalities, Linear Programming, and Propositions, with the theme Navigating the World of Mathematical Optimization and Logic. This is our conceptual framework for system of linear inequalities, for linear programming, and for propositions. Our objectives are: first, to understand the fundamentals of systems of linear inequalities and how they are used to represent constraints in mathematical models. Second is to explore the concept of linear programming and its application in optimizing resources and decision-making. And last, to delve into propositions and logic to enhance problem-solving skills and critical thinking abilities. Now, let's begin with defining what is linear inequalities. Linear inequalities are defined as expressions in which two linear expressions are compared using the inequality symbols. So the 5 symbols that are used to represent the linear inequalities are not equal, less than, greater than, less than or equal to, or greater than or equal to. So now that we already know what this linear inequality means, let's move on with the system of linear inequalities. So the word system there implies that we are going to graph 2 or more linear inequalities at the same time. For example, we have these 2 graphs from a system of linear inequality. To know their solution, we have to combine these 2 graphs into one Cartesian plane. So as you see, they overlap in this area. So it means that any point in this area is their solution. The solution to the system will be the area or region where the graphs of linear inequalities in the system overlap. And that solution is what we call the feasible region. The feasible region is the area on the graph where all the shaded regions from the individual inequalities overlap. It is the region where the solutions to all the inequalities in the system satisfy all the given conditions at the same time.
I will be discussing about the graphical method for the systems of linear inequalities. This is for the solving for the system of linear inequalities by using graphical method. Let's say, for example, number 1. Solve the system of inequalities by graphing. So, y is less than equal x minus 2. So, first, graph the inequality. So, y greater than equal x minus 2. So, the related equation is y equals x minus 2. So, since inequality is like less than equal, it is not a strict one. So, the borderline is solid. So, let's first graph the straight line. Okay, so consider that that is not on the line, let's say 0, 0, and substitute in the inequality. So the line is false. So the solution does not contain the point 0, 0. So shade the lower of the half of the line. So okay. So similarly, draw a dashed line for the related equation of the second inequality. So, y is greater than negative 3x plus 5, which has a strict inequality. So, the point, it doesn't satisfy the inequality. So, shade the half that does not contain the point. Intersection region of the solutions of the 2 inequalities. So, this is the result. Real-world examples are like applications in system of linear inequalities. So, let's say, for example, for the profit maximization. So, a business might want to determine the optimal mix of products to maximize profit while considering production constraints. So, let's say, for example, if the profit on a product A is $5 per unit, And on the product B is $4 per unit. So the objective is to maximize the profit or the P. So the formula for this, or like the solving for this, is P is equal to 5x plus 4y. In conclusion, systems of linear inequalities are powerful tools to use in various fields to model in and solve problems.
Good day, ma'am. I'm Almario Jethroqued, and I'm going to discuss the topic of linear programming in mathematics. So, linear programming in mathematics is a powerful method used to optimize a linear objective function while adhering to linear constraints. It serves as a valuable tool for finding the best solution within specified limitations, guiding decision-making processes across various applications. Now, the primary goal of linear programming is to maximize or minimize the objective function under linear constraints, enabling efficient resource allocation and optimal decision-making. Moving on the components of linear programming. The first is the objective function, expressed as maximize z equals c1 x1 plus c2 x2 plus dot 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 plus cn xn. Involves coefficients such as c1, c2 dot 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 cn and decision variables x1, x2 dot 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 xn. Next is constraints, represented as linear inequalities or equations like a1 x1 plus a2 x2 plus dot 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 plus an xn less than or equal to b. Include coefficients such as a1 x1 dot 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 an and a constant of b. The last one is decision variables such as x1, x2, dot dot dot, xn are the unknown quantities crucial for optimizing the objective function within the defined constraints. So understanding these components is essential for effectively applying linear programming principles to solve complex problems and enhance decision outcomes in mathematical optimization.
Solution techniques. The following are the steps for solving linear programming problems. First is determine the choice functors. Second is develop the objective function. Next is determine whether the function should be decreased or maximized. Next is record the limitations. Lastly, verify the decision variables are either larger than or equal to 0. Next is simplex method. Simplex method is an approach to solving linear programming models by hand using slack variables, tableaus, and pivot variables as a means to finding the optimal solution of an optimization problem. Next is interior point method. Interior point method are often used to solve linear programming problems and can also be used to solve nonlinear programming problems. They typically employ a two-phase approach, with the first phase to find a feasible solution and the second phase to refine the solution to optimality. 3D practical application. Linear programming is used in business and industry, in production planning, transportation and routing, and various types of scheduling. Next is resource allocation. Linear programming can also be used to mathematically optimize resource allocation by formulating constraints and objectives into a linear mathematical model, enabling decision makers to allocate resources efficiently and effectively to achieve desired outcomes. Lastly, production planning. Linear programming, or LP, can be applied to production planning to optimize resource allocation such as labors, machines, and materials, and also it helps in determining the optimal production quantities to meet demand while minimizing cost.
Hi, I am Robin Nanyora, and now I'll be discussing about the proposition. So it is a declarative sentence that can be classified as true or false, but not both. We use variables to represent proposition like P, Q, and R. An example of this is grass is green. So this statement can be objectively true or false depending on the type of grass I'm lighting. So proposition is important as it serves as a fundamental unit in logic. It also allows us to identify logical fallacies in reasoning, analyze statements about possibility, necessity, and obligation, and allows us to understand the relationship between statements. So there are two types of propositions, the simple proposition and the compound proposition. So a simple proposition is a statement that is singular in nature and conveys one thought. Example, a triangle has three sides, so it expresses a single complete idea. There is no combination of other concepts within the statement. It simply states the fact about triangle. Next is compound proposition. It contains two or more simple propositions that are put together using connected words like not, and, or, if, then, and etc. Example, the sun is shining and birds are singing. The connected word that we use here is the word and. This compound proposition is true only if both individual propositions are true. And lastly, we have the logical operators. It is also known as Boolean operators. This is a symbol in logic and computer science used to perform operation on propositions with true or false value. They combine simple propositions to create compound propositions, determining their overall true value based on their individual truth values. Example of these are and, or, not, if, then. Like if you study hard, then you will get good grades. That's all. Thank you.
Hello, good day to you, ma'am. My name is Salary Algatayo, and I will going to discuss to you my part about truth tables and the application of mathematics. So let's start with the truth table. In the truth table, each input variables like p, q, x, y, a, and b has its own column. And there is final column that shows all the possible outcomes of the logical operation being represented, such as and, or, not. The table helps us see how the logical operation behave based on different combination of truth values for the input variables. A truth table is like a special chart that helps us see if a logical statement is true or false. It shows all the possible combination of truth values for the part of a statement and help us determine the overall truth value of the statement. So however, truth table has various types such as NOT gate, AND gate, OR gate, NAND gate, NOR gate, OR gate, and XNOR gate truth tables. So let's discuss the NOT gate first. NOT gate or an inverter truth table is a simple logical device that has one input and one output. Its function is to produce the opposite output compared to the input. So the NOT gate is like a switch that changes the input when the input is on. The output is off, and when the input is off, the output is on. It's a device that gives the opposite result of the input. So the next is the AND gate truth table. So the truth table for an AND gate shows the output based on the combination of input values, and an AND gate has two inputs, and the output is only one, or is only true when both inputs are true. So when both inputs A and B are 0, the output is 0. This is because in the AND gate operation, both inputs need to be true for the output to be true. Since both inputs are 0, the output is 0. So it follows the rule that both inputs must be true for the output to be true. So the next is the OR gate truth table. The OR gate is a fundamental logic gate that can have multiple inputs but only one output. In an OR gate, the output is 0 only when all input bits are 0. So if any input bit is 1, the output will be 1 based on the truth table. So an OR gate is like a switch that turns on if at least one input is on. It's like a group decision. If anyone says yes, the answer is yes. So let's proceed to the other part of my topic, which is about the application of preposition in mathematics and logic. So firstly, in the logical reasoning, prepositions in mathematics and logic are fundamental building blocks for logical reasoning. A preposition is a statement that can be either true or false. In logical reasoning, prepositions help us form arguments, make decisions, and draw conclusions based on the given information. So by analyzing the truth values of preposition and their logical connections, we can evaluate the validity of arguments and make informed decisions. Prepositions serve as the basis for constructing logical structure and reasoning processes in mathematics and other fields. So, however, in the other hands, problem solving is preposition plays a crucial role in problem solving by providing a clear and precise way to express statement and conditions in mathematical problem solving. So, preposition helps define the conditions, constraints, and relationship between different elements of a problem. So, by formulating prepositions and logical statement, we can break down complex problems into manageable parts, analyze the relationship between them, and derive solution based on logical deductions. Preposition guide the problem-solving process by setting up the framework for reasoning and decision-making. So, no, it's enable us to navigate through mathematical challenges effectively. And that's all for my part. Thank you for listening.